Hello, hi Justin, hi Dora. Dora, take it over.
Did Dora freeze?
Oh, I think she froze.
Oh no.
Okay,
Hi,
You're
hi
back.
everyone.
hi. Take it
Yes,
over.
I had a
You froze
connection
for a bit.
problem. Yeah. So, hi everyone. Welcome to today's section. I am Dorra Bukhari. I'm an active member of AWS community and founder of AWS user group in Tunisia. Hi guys. Um, I'm happy to be with you in this session, and we will go together to learn new stuff and to share knowledge. Today, I am honored to host Justin Garrison, author of an amazing book entitled The Cloud Native Infrastructure with Krisnova, conference speaker, and active AWS senior developer advocate. In fact, some call him the Kelsey Hightower of AWS container world. His production in kubicorn made him the cloud native ambassador. In fact, YouTubers call him the Spielberg of cloud native. Justin, with further ado, welcome virtually to other side of the world. Take over.
Hey, one day it'll be great to actually come out in person. Year and a half into this, and hopefully things change. But thank you so much for having me. I'm very excited to show off what we're doing at Amazon with EKS-Anywhere, and wanted to bring it to your audience and talk about it, and then let people see kind of early demo of what we're doing. So, and if
Thank you,
anyone watching in the chat, feel free to reach out, ask questions as we're going. But yeah, I think it's gonna be great.
Thank you.
So if anyone's familiar, EKS-Anywhere was announced last year at reInvents. It was a pre-announce of, hey, we're working on something to allow people to run EKS wherever you have your own infrastructure, and wanted to take a step back from that and talk about like what problem it's solving. And for me, it was 2015, and I was working at a company with a lot of on-prem infrastructure, and Jira ticket came in, and I was just rolling off of one project. It was just about wrapping up and kind of going through the backlog and saying, hey, what's coming up next, and what should we be working on? And there was a Jira ticket that said, allow the web developers to self-service deploy applications. I kind of thought about it a lot, and I was just like, okay, well, what does that mean? Like, do we have self-service now? And we didn't really. We had, physical machines they could go through purchase orders and planning to buy if they're building an app, whatever it is they're trying to do. And then there was another side of it of like, we had VMs, and the API for our VMs was basically send an email, right? Like if they wanted to request a virtual machine to run a new app, they had to send an email to someone, and they'd get it back, a day or two, and say, okay, here you go. Here's your IP address. Here's your machine name. I had to specify memory and whatever else. And they could, from there, log in and say, okay, well, this is how I want to manage this machine. There was automation in place if they wanted to use it, but they didn't really have to. They could just go ahead and SSH and git pull their code or whatever it is if they need to install Ruby or NPM, whatever it is they were deploying. So this is, again, 2015-ish, and containers were around. They were, people were starting to talk about it. I was playing with Docker and a little, here and there. And so we were looking at like, what does this actually mean? Like, how could this work for them? And so starting to get them to package applications as containers and say, hey, you could run this container on a VM. Like, you'll request the VM and then package your container and then just run the container. And it worked. It was great. Like, we were able to get some base images in there and all that, but there was still like, oh, I had to like send this email. There was no API for them to self-service and kind of deploy it. And there wasn't a whole lot of tracking besides like at the machine level of like, hey, are you using this VM? Hey, the CVE's out, or something happened that you need to upgrade that VM. Like, there was all these shared responsibilities between the different teams, and it was still a little difficult. So I started looking at Kubernetes at the time and was like, how does this fit with what we want to do? Could this solve our problem for our developers? And it was hard. It was on-prem. There was a lot of just, how do you get Kubernetes installed onto machines? Like, we can install an OS. How do you layer the Kubernetes bits on top of it? And there was a lot of options, and there's just so many things that was like, what sort of networking do I need? How do I need to, is there like tuning at the kernel level? Like, what are the things I actually need to install this? And then we had existing systems for all of our, automation for installing operating systems. So like, how does this Kubernetes thing tie in with that? And it wasn't something that was straightforward. Looking at what we could do in Amazon, and we said, hey, like AWS, there's a lot of shared services that are implied and just understood of like, hey, S3 is there, metadata is there, identity for, metadata for like how the workloads are working, and then also like tags based on the machines. Like, all that stuff just existed because it was in Amazon, and like, hey, but like I can't replicate all of that on-prem. So like, where's the balance of like what I needed to do with Kubernetes and what the devs wanted for their deployments? We're able to obviously, deploy Kubernetes, got some web developers into it, got apps deployed, and it was great. Like, we were able to like make those decisions for ourselves. Some of them were right, some of them weren't so good looking forward. But that was, the path we went on and how we actually enabled some developers to do this. And it was a big win for the teams that wanted to do that. There was no more email. We had shared clusters for certain things, and we could say, hey, deploy your apps here. Here's your endpoint. Here's your authentication. Here's how we can get your apps in there. And then we could track some of that based on tags. We could do reports a little easier than what we could before with VMs. Fast forward about a year, krisnova and I were working on this book, Cloud Native Infrastructure, which we wrote together, which taught me a lot about what it was I actually was doing, what Kubernetes was actually bringing to the table. And at the time, I was just figuring out the tech bits and saying, how do I put these things together? And in reality, it was teaching me how to use my infrastructure a little different. Where we have infrastructure as code, and infrastructure as code says, hey, we have a repo of some sort of text-based files, and those get interpreted and then managed by some process that says, okay, now make this happen, right? Like, I have CI/CD of Terraform or CloudFormation or whatever, and I say, okay, when I commit code, I want something to happen over at the other end. And that was great because that automated a lot of things, and it reduced a lot of problems that people typically had. In this case with Kubernetes, we could define some things as data, but we weren't actually like applying them one off like that. In this case, Kubernetes switched some of those things, and it actually taught us to use our infrastructure as software. This wasn't a one-time commit. This wasn't a repo of just files. This was continually running replication controllers around, just controllers that said like, hey, what's the current state of the world? What state should it be? Let's make that happen. And it wasn't on a code commit. It was always. It was anytime anything changed in the infrastructure, whatever the piece of software was designed to control, it would watch for changes. And it said, hey, if something changed, what's going on? And this was a pattern that was deeply ingrained in Kubernetes. This isn't something that's like, oh, Kubernetes kind of does it. No, like every controller, this is what it's doing. We have a central API that defines like where things are controlled, and then we have all these controllers that loop over that. And so the main, TLDR, if you don't really need to read the book, infrastructure as software is the way to go. Where infrastructure as code still has drift. It helps with a lot of things. Infrastructure as software is one level up past that and says, hey, we're still going to define our infrastructure in these text format, but we need it to continually apply. But doing this one-off on a push doesn't work, because what happens when you don't apply infrastructure for 6 months or a year or whatever? Like, the drift that happens in the massive shift that has to happen for that to actually come about and say, hey, what is the current state of the world and what does my repo say? You just start getting errors, and you have to go modify things, and you have to like slowly step towards that thing. So if we can lower that or shorten that loop, we can always make sure our infrastructure is what we want. So infrastructure as software is the key thing we wanted people to take away from this book, of saying, hey, here's how Kubernetes does it. This is why this is a good pattern. You also can do this in AWS. You can do this in your cloud. You can do it on-prem. You can have software that's always looking at the state of the world and continually reconciles based on that. And the pattern's not new. I mean, robotics did this. That like if you talk to anyone like back in the day of Kubernetes, like they was like, well, robots like needed a balance, and they continually looked at like where they were, how they were standing, stuff like that. But also things like chaos monkeys. Like Netflix has these chaos monkeys, which were software that runs, and it kind of did the opposite of what we typically want with infrastructure as software, where it's like instead of like making things the way we want it, it actually continually runs and sometimes breaks things. But it's a piece of software. It's not like, hey, I'm running this chaos monkey when I commit code. It's like, no. It's always running, and it continually does, so that we can get those measurements. That's the point, is to teach or to treat our infrastructure just like the applications we deployed. We're great at deploying apps, web apps, making all that stuff work, scaling, metrics, all that stuff. We've solved that problem in a lot of ways, but we never really transitioned that to infrastructure. After writing this book, Chris went out and built basically a prototype of what she had in her mind of like, this is how this should work. And kubicorn was the initial take of like, what if Kubernetes could manage Kubernetes? What if we could take this control loop pattern, this centralized API with control loops, and deploy and manage Kubernetes? That like just treat Kubernetes as another application. Kubernetes is already managing infrastructure. It already does load balancers and storage and all these things. So like, let's level that up one more and say, okay, well now Kubernetes can manage Kubernetes. How does that look? And this was a great example of doing that, where it's a single binary. It did a lot of things for you. It made some assumptions around, hey, maybe you don't need like every configuration, every knob that's might be possible, because we're going to have some opinions about how we run the infrastructure, how your Kubernetes is configured, and CNI or storage or whatever. Like, we'll make some assumptions for you off the bat to give you some sane defaults and what we think is the best use case. And that's what was codified here in kubicorn, and said, okay, this is how we want this to run. You can run kubicorn and get basically a cluster that is managing itself. Out of this project came the Cluster API project. Let's zoom that a little more for you. This is a SIG inside of Kubernetes, which took that kubicorn and said, well, let's make it generic. Let's make it so that we could do this for anything. We want to manage these, clusters, but we need some other like pieces here for knobs, just like a deployment in Kubernetes, where I deploy my application. And if I say I want a deployment, I get a replication set, which is like how many of the thing I wanted, and versioning. And the replication set creates pods. And so from that, I get like a tier of how this is working. And so similar, Cluster API has machine sets and machines. And from that, you can say, hey, I want a version of a machine out there, and I need that to roll into my cluster. And just like your deployments in Kubernetes do the same, you get deployment, replica set, pods, like you get, machine sets and machines from Cluster API. And so this was a really cool pattern. And one of the neat things about this was it didn't make as many assumptions about what you had. Your assumption was you had Kubernetes. Everything else is driven from the Kubernetes API and the controllers from that API. So that was, lowered the barrier for people on-prem or people that maybe couldn't use a hosted Kubernetes service. And we said, hey, we don't necessarily know where you're going to be running this. So let's just collapse all of this information we needed and use Kubernetes native metadata and annotations and config maps and secrets and everything that Kubernetes provides us. And how do we make Kubernetes manage itself based on this? And so a really cool thing that Cluster API focuses on the core API for what these, how this runs. And it's mostly a set of custom resource definitions, CRDs, that then have controllers that act on them, but they don't actually do a whole lot. They help manage like some state and like how things transition. But the thing you actually want is a provider. Essentially, you want a Cluster API like piece that actually goes and provisions your infrastructure. And so Cluster API does that with plugins. So they have a plugin-based system for different providers. And so there's an AWS provider, and there's a on-prem like VMware provider, and there's a Docker provider, and there's all these really cool plugins that anyone can contribute and say, hey, I'm going to look at this API and this spec, and then we have a separate project that you can deploy and then manage it based on this provider wherever you're running, which is a great model. Just like Kubernetes, it gives you all the flexibility in the world, and it allows you to really pick and choose what it is that you're trying to do with your infrastructure, and where you're trying to do it. So if you're running it on-prem, there's, like I said, there's VMware, I think there's an OpenStack, there's local Docker, there's like some raw like SSH ones. Like it's really flexible. And so it still says, hey, let's plug everything into the Kubernetes API. And that's where we're storing our state of the world. And all these controllers continually replicate or reconcile based on that state. And if it ever drifts, they go ahead and make that change. This is super powerful. One of the things that came around from this was sometimes it's a little complex. The complexity of Kubernetes, the flexibility of Kubernetes leads to some complexity. When we look back at kubicorn, single binary, made some assumptions, kind of self-managed, and was able to do this thing. And then when I switch over to Cluster API, looking at, okay, now I need the centralized CRDs, I need that controller, I need a provider, I need some other things. I also need to make decisions about what's my CNI, what's my storage, where am I running this? All those sorts of things you can do it. It's a great model. Like, treat your infrastructure as software, keep doing that just like you would your applications. But what we saw inside of Amazon is we saw people that wanted to do some of this flexibility, but they also didn't have the operational experience of someone that had been running Kubernetes at a certain scale for a long time. And it was hard for customers or users of Kubernetes to say like, hey, I want to go do this thing. I want to run it on-prem. And there was just no way for them to do that. And like leveling up to the, hey, I want someone to actually make some of these decisions for me. And I want someone to drive, give some support and make this a little simpler. Which is exactly what we wanted to do with EKS-Anywhere. So when EKS-Anywhere was announced, this was the goal, was how do we bring all of the operational stuff that we've learned at EKS? Because EKS is, managed Kubernetes. We run, I don't even know how many clusters. It's a ridiculous number. And we've been doing it for years. And it's great because we've learned a lot through that. And there's so much stuff that we can say, hey, you know what? We understand some of the best practices or some of the opinions that we have on hey, maybe you just all of the options, try to focus on this one because this is the one that we've had the best success with. And that's what EKS-Anywhere is doing. EKS-Anywhere says, okay, well, let's boil all that down. We can use this pattern, this Cluster API pattern, and take the CRDs and the controllers and the providers and bundle those back in with some, assumptions, or at least some best practices of what we think, hey, this is probably same defaults, just like kubicorn. It's let's give you some same defaults and let you run, be successful without needing to make all the decisions you had before. And there's still one little piece here that was kind of missing, where we realized EKS that we were running, we had to maintain those bits ourselves. We were pulling upstream directly from Kubernetes project, but we had to make some changes sometimes. We had to backport CVEs. We had some minor tweaks and things that had to go into EKS to help customers be successful and to say, hey, how does this look for a customer at a certain scale? And what are the actual critical things that we need to run? And so last year, we actually open sourced EKS-Distro, which is the bits and patches that we run in EKS. Open sourced it and said, hey, here's some changes that we had to make to upstream Kubernetes to make it work in EKS at a certain scale with certain assumptions. These are the things, and security and patches and settings. And there's some things, it's not a whole lot that you can go in the GitHub repo and you can actually find the patch list of hey, here's the, 4 or 5, maybe 10, whatever patches that we had to apply. Most of them are an upstream, here's a patch that's coming in, and we rolled that in a little quicker because we had people that had an issue. And once you get to a certain, a 1 in a million bug or something, it's okay, well, if I have a million of these, it's going to happen, right? There's those situations where we had to help customers quickly. And so having EKS-Distro we can manage those patches, we can support those patches, and we open sourced it for everyone else. So you actually can look in EKS-Distro, again, completely open source, out there, use it. There's a bunch of partners that actually ran with EKS-Distro and said, hey, we're going to either offer this as defaults or offer it as a flag to say, hey, do you want the upstream open source Kubernetes, or do you want the Amazon EKS-Distro version of it? So things like micro-K8s and different deployers of Kubernetes can actually pull these bits in instead of directly from GitHub Kubernetes releases. So it's a nice feature that we've been able to like pull in and open source and give back to the community and say, hey, if you want to like some of these things, here you go. Like this is part of our regular release. Whenever an EKS has a release, like we also are releasing EKS-Distro because that's what we're using to deploy EKS. But now we have, so that's like the last little piece that was missing. This, what are we using to make this happen? Like what are the bits, the core bits of Kubernetes? And then now we layer on, how are we going to operate this? How are we going to actually roll this out? How are we going to make it possible for a customer to do this in their own data center? And that was the goal, was, hey, let's make you successful. Let's help you if you're running Kubernetes on-prem. Actually, this isn't actually slides. If anyone was wondering, I don't have a slideshow. I don't tend to do slideshows. This is a whiteboard. So I just want to show a little bit of what we were just talking about. Obviously, like hopefully this is clear to anyone that's watching here. Where here's my code. Here's the thing that I have that I say this defines my spec. It's a declarative spec against an API, and oh, I forgot when I screen share it, I'll slow this down. I can't write as fast as I normally do. I take this spec, this whatever it is I'm deploying, I say, API, go do this. And then we have these controllers here, these replication controller, or these reconciling controllers that look at that thing and they go make changes to something. We say, okay, that controller looks at that state and says, is this what I want? Yes or no. And it makes a change if possible. And that end thing, the thing we're changing, can, again, it's been deployments, it's been pods, Cluster API, it's clusters, and we're able to do that from this same model. There's nothing here that's changed. There's nothing that's different about the model, and it helps you kind of understand where things break too, because you have a consistent model. It's not, hey, I have a problem somewhere. You don't need to like find, okay, well, this repo has this piece of the code, this repo has this piece of the code, this API, has this state. Like it collapses a lot of those problems into a single point of saying it's in the API. I can go find where this is. And yes, any questions? I see them coming in chat, so keep them coming. We'll address some of that in just a minute.
Yes, there's a lot of questions here. We'll have a section for questions and answers later.
So let's show you. Let's just show you workflow on how this works and what you can do with it. So this is an early beta of EKS-Anywhere. So nothing is actually like concrete on this release, but I want to show it anyway, just so we can understand the workflow. And just like I was saying earlier, Cluster API has these pluggable provider models, and we're doing a similar thing. So we can extend what it is that's, where people want to deploy Kubernetes clusters. And at start, I'm going to show off the local Docker provider. So I'm going to run a EKS-Anywhere cluster locally, just like you would with Kind or something, but it brings in that spec, the workflow, and the operational excellence, even for a dev cluster, because we're always going to run it in a certain way. And then we have other providers on-prem, VMware, and working on like bare metal and stuff coming in the future. But just the workflow in general. Control. The interface for most people, at least getting started here, is going to be EKS Control, which is our command line tool for EKS in the cloud, hosted. But EKS Control is a great interface for people to manage things. It does do infrastructure as code, where it's spitting out text files in YAML and then sending that data to an API. the standard commands here we're going to have is just like you would have in hosted under Anywhere. Subcommand is, create a cluster, delete a cluster, upgrade a cluster, and check versions. One thing we're going to look at here first is the generate command. So if I generate a config, this is going to generate a spec for me, so I can modify this spec, and then my controller is going to take over from there. So I got to give it a name. So hello, and I got to pick a provider, which is where I'm going to run this infrastructure. So we're going to run it locally, and it's going to give us how I would run EKS-Anywhere on top of Docker on this local machine. Oops. I want to generate a cluster config. That's like the whole spec. If you've been using Kubernetes, this spec, this data structure looks really familiar. Here's some of the things, like some of them are options, some of them are, our best practices on like what we think you should be using, especially on-prem. So like a CNI provider, Cilium. We love Cilium. I love it. I've been using it for a long time. Great eBPF based network overlay. And then some other things like control plane configuration. If you have, how your control planes can be set up, how many you want, your data center, which is like where this is run. This is based on the provider. So you have a configuration based on that provider. So here with my Docker data center provider, I don't actually have anything to configure because it's going to look at local Docker. But for say VMware, you might have to set up a data center or storage or templates or whatever it is you want to use. You can configure that as code and use that as part of your configuration setup. And then things like what version of Kubernetes do you want? How your workers, like how many workers do you want on the data plane, and what configuration should they have, as well as etcd. All right, like the main components of a control plane for Kubernetes are the API server and etcd for the database. So in this case, we're going to split those up into two separate containers on my local host, and I'm going to have a one worker machine, which is that further data plane. One of the questions I saw here, Debian or Fedora or something else. That was another assumption we wanted to bring to people, which I actually forgot to open a tab for. By default, I think it'd be great if people use Bottlerocket. Bottlerocket is AWS's secure container-based OS. We made this and open sourced it a year and a half ago, 2 years ago, as you can run it in EKS or in AWS now. It's not specific to EKS, but it is for running containers. So there actually is different versions of Bottlerocket. There's currently one for ECS, and there's one for EKS, that you can take this OS and publish it or run this as your OS, which is just for running those containers. I did a Containers from the Couch episode. I actually did 2 of them on Bottlerockets last year, because I'm a fan of these container-based OSs, and Bottlerocket has some very they are unique, but it's very strict boundaries around where workloads are running and where you can control things and change things. So we want it to be a immutable OS, and only for running containers. So it's not a general purpose Linux. It's not for something that you want to just like, oh, I'm going to use this as my, like my normal laptop OS or something like that. Like, no, this is for running containers inside of an orchestrator. And so we want to have it really tightly coupled to orchestrators and say, hey, how does Kubernetes want to do something? We can get some configuration and we can make some assumptions based on that environment it's running in, and that every workload is a container. So that's default. There are other options, like if you want Ubuntu or something else, like we have you can add custom templates, things like that inside of EKS-Anywhere. But the defaults we think is a great option to have Bottlerocket. So let's look back at this configuration real fast. Let's save this out to a file. And I actually want to modify it real fast because I do want to show one other thing. We're going to change the version back to 120 instead of 121. We're going to show an upgrade real fast too. So if I want to take that spec that I just saved out. Again, Docker, I don't need to change anything. A lot of the things that I wanted was, just deployed similar. Again, like if you're deploying kind, there's plenty of ways to run Kubernetes on a local machine. Minikube are all options, and we're enabling that as well with EKS-Anywhere. So anyone that's used Kubernetes at all for any amount of time, you're going to be used to this workflow. You take a spec file and you deploy it, and you say, okay, now I want to create the thing from that spec. And so this is going to make that cluster for me. I see some more questions here about AL2 and EKS-Distro.
I cannot hold it anymore. I need to ask.
What's up?
Yes. So this is great. So basically, you are using EKS control to create a cluster using a cluster API provider. Is that right?
Yep.
And for someone to start today, what should they do?
Wait till it's released.
Because it's not GA yet. I mean, we were thinking that maybe during the America Summit, maybe we should hear an announcement. But usually the summit, you don't hear an announcement, do you?
We're working hard to get it out as soon as we can. We want to make, again, we've had a closed beta with some customers, and we wanted to get their early feedback on like, hey, what assumptions maybe did we have about the environments of where they're running? Because if you worked in a data center, everyone's different. Every single data center has some unique thing about it that's like, oh, well, we do it this way. There are some common assumptions, and there's some common things that we've seen at a lot of places. We say, hey, what's something that at a certain scale customers are going to have? And in most cases, like VMware was very common for any environment that said, hey, well, we run VMs based on, on this metal. And so we wanted to target, okay, well, let's look at VMware first. And let's say, okay, how do we make someone successful with EKS control or EKS-Anywhere on top of VMware? And so that was our primary focus, but also this Docker provider to let people play with it and say, okay, how is this actually working? What are the components of this? And if you watch this text coming out, one thing that's actually kind of unique about EKS-Anywhere is something that Chris did with kubicorn, which we call the bootstrapping problem. And so if I find my whiteboard again, so one of the things that here, let's just mark up this picture and say, I took my spec and in this case, I'm running it locally in Docker, but it's the same workflow for pretty much anything, where it took that spec and then it created something that we call a bootstrap cluster. So this API, we need an API before we can do anything. And we need controllers based on that data. And so what we're actually doing is taking this initial spec and we're creating what we call a bootstrap cluster, which has the API and these controllers. But this isn't permanent. This is the piece that we say, okay, we need to take the data and we need to do something with it. So what we actually do is once this workload cluster is available, we take these we take the controllers that were in the bootstrap and the data that we had, and we bring it over here to this final cluster. And we say, okay, now you run yourself. Now you're fine to be able to manage yourself. And then we can, at that point, get rid of this bootstrap cluster. We can say, hey, you know what? Like, we don't actually need that piece anymore. And now all the controllers and everything else we're doing is happening over here. And so any future commands, like we can just talk to the cluster itself. This is great at a small scale. This allows for a lot of people to say like, hey, what was that spec? Like, this isn't something that as someone runs a local bootstrap, cluster on my machine, it's not something that like, oh, everyone has to like share my computer or something like that. It's like, no, like this is just to get things started. Same thing with kubicorn, same thing with other things that need to bootstrap and get in place. We wanted a mechanism to allow that to happen. But the end result is something here in a cluster, whether that's a one-to-one mapping or that's a one-to-many mapping. In the Cluster API reference diagrams, they actually have, this is a management cluster. If you look at Cluster API, and then this creates more clusters. And so you're any person in ops, any person that's managing the clusters, they have a central API that they can work with and say, hey, I need one place to be able to view the world of all my clusters. And then that is responsible for going out to these other clusters. So it's this tiering approach, which is working really well in Cluster API because it gets you to a specific scale of, I don't want to have one-to-one mapping, but at a small scale, one-to-one mapping works really well because it gives freedom to that team and say, hey, you can own this cluster and everything you want to do to it. If you have the responsibility and the controls in place, you don't have to go send that email or talk to a central team. And so right now it's with EKS-Anywhere, this beta, it's one-to-one mapping, but we are looking at like this management cluster, how we fan that out for the future.
Great. When you say cluster management, it's responsible for provisioning cluster and making sure the cluster at the desired state as you defined it. However, it will not manage like multi-clusters in terms of workloads, correct?
Right. This isn't federation. This isn't something that says, hey, we want all these clusters to work as one. That's not actually the goal here. The goal is, how do we take a single point and manage a lot of clusters? Same thing like when we were doing configuration management, right? Like I had 100 servers, but I had one repo that I could look at and say like, okay, I'm going to push this into Git. And then I have one repo to understand. And in a lot of cases, like you could kind of trace back, like what is the manifest file or what is this like state for this machine supposed to be? But it was stored in one place. And then like little controllers, I mean, configuration management had a very similar model where they had these little controllers that worked at a machine level. It wasn't at a multi-machine level, but it was per machine. What's the configuration supposed to be? What is my etc host file supposed to be? How is my sudo or file supposed to be? And we did that at this configuration code, but we had a single repo. And in this case, it's an API. Infrastructure is software that does those controllers. And so this allows us again to manage multiple things, and you have some automation you can build between that coordination. But yeah, you're right. It's not for workloads like, hey, I need this workload in 10 different clusters. You need something different that is workload focused for that. This is very specific to the infrastructure.
So this could be something on the AWS console later on, or a new console probably, or something.
Yeah, absolutely. We would love.
We haven't seen yet.
We would love to have an opportunity for people to say, "Hey, again, EKS-Anywhere is designed for your data centers, but how you view and manage those things, we would love it if there's a way that you could, get to the EKS console and be able to see like, oh, where are my clusters? Especially if you're hybrid, right? Like you have EKS clusters, but you also have on-prem clusters. Having different areas to view those things gets difficult, and so a lot of people want to collapse that to a single pane of glass. You don't need it for everything, but depending on what you're managing, it's super helpful.
Yeah, I think Mohammed was asking the question, and he's making analogy with storage. But the other thing, when you were talking about this EKS-Distro, you mentioned that there are other vendors that were interested in it. One of them is Rancher. So do you expect Rancher to have the multi-cluster first, managing and pushing policies and stuff like this, RKE2?
And Rancher works sometimes at a slightly different level than like the raw infrastructure, because Rancher does add a lot of value on top of, like, you can get a little more insights into workloads. You can do some things that if you're provisioning infrastructure, which it also does, it's not a one-to-one comparison always. So Rancher, I know, is working a lot on getting multi-cluster supports, and I think that's for managing multiple clusters configuration, but also for the workloads. And so they're they're tying that together and saying, hey, we want this to be a one-stop shop for everything that anyone's that interacting with Kubernetes is doing. In this case, go ahead.
Go ahead. No, yes.
In this case, EKS is focusing on infrastructure. And we say, hey, we're going to vend you a Kubernetes cluster, and you do whatever you want on top of that. This is just Kubernetes at the end of the day. So anything that was working in Kubernetes before is still working in Kubernetes. And it's compliant Kubernetes through and through of saying, you wanted a Kubernetes API? Here, we're going to make it easy for you to manage that Kubernetes API.
Okay. Sorry for the interrupt, but
no, the
I
questions
really
are
wanted
great.
to ask.
Yeah, I'll show off a little bit here too. Also, like, this cluster is created. If I look at my local like Docker I have these components. These are containers that are running on my machine, which are all like part of this Kubernetes cluster. I have my etcd, I have a worker node, and I have the control plane. And so after we create a cluster, what we do is we basically spit out a kubeconfig file in the directory wherever I ran it. So if I look in my hello directory, I can see I have this kubeconfig file that allows me to now, okay, it did all the certificate provisioning. It did everything that I needed to get started. So the next thing I just need to do is actually use the cluster. Like I said, it's just Kubernetes at the end of the day, with opinions on how you manage it and how we want that configured initially. So even at a Docker level, I'm still doing some of those things that make some of that transitioning into from a local configuration change to a production system a little more consistent, because I can kind of trust that like some of the configuration and some of those assumptions are the same. So if I let's just get pods, because obviously everyone gets pods. On tab complete. What's it called? I can't remember. What's the name of it? There it is. Let's just do that.
You should alias it.
Yeah, I can export.
Or export it.
And we can see here, like I said before, some of the things like this is using the providers from Cluster API. So here's CAPI, which is Cluster API provider for Docker. CAPI, these are the admin control planes. So these controllers are running. And so if I look at my CRDs, I can see the same thing that I was talking about that come from Cluster API. So I'll see these cluster X Kubernetes, these Docker machine pools and the Docker machine templates. And these are all specs that exist inside this cluster that allow these controllers to do what they're supposed to do. And that's how the controllers can manage that infrastructure state and say, okay, now we need to migrate things. Now we need to change things. If you have a configuration drift, that's how it puts it back. So the last thing I was actually wanted to demo here was, hello, if I want to upgrade my version, right? Like how am I supposed to upgrade these Kubernetes clusters? This is like lots of people have Kubernetes clusters. The day two concerns are very difficult for a lot of people because you have a lot to consider here. And just like default for configuration in Kubernetes for a deployment, a rolling upgrade works really, really well for a lot of cases. And so if you have obviously a production cluster, you're going to have multiple, you're going to have 3 etcd, you're going to have a couple different API services. There's not going to be a downtime. In this case, in Docker, I have a one-to-one, one of each. So I can't guarantee there's no like downtime locally. But if I look at do cluster, that's not it. I'm gonna tell EKS-Anywhere, the Anywhere plugin, hey, I want you to go ahead and upgrade this cluster for me. And oh, I did it wrong. I do need cluster. So this again just verifies that spec. And you'll see down here at the bottom, I'm gonna get this initial container is my bootstrap cluster. So in this case, because it's a one-to-one mapping, I don't have a centralized management cluster. I'm going to create a bootstrap cluster for it again and put all this data into that cluster and then manage the second cluster with it. And so as this goes, you'll see I already have another control plane coming up 17 seconds ago. That's version 121. And so that's going to do a rolling release of my control plane and then my worker nodes, and we're just codifying all of these best practices we've had for Kubernetes for a long time now to say, how do we do a rolling release of a cluster? How do we, do that for software? And this is going to do the exact same thing that we normally would do in a hosted EKS cluster too, of doing those rolling releases. I saw that other question. Where'd that go? Oh, accessing services. The same way you would anywhere on-prem. You get an identity for a workload, and you're able to, take that and use that identity in your workload into AWS. And so there's actually no difference there of like, this isn't special sauce around, this is like, this cluster is like a unique AWS entity. This is something that works just like your other on-prem software. If you need to talk to S3 or ECR, you can create secrets for that. If you have like direct connects or whatever it is that how you're talking to AWS, you manage those just the same way you do with all your other on-prem software talking to AWS. There are some projects out there that we're working on as well. Let me find. You're trying to provision AWS resources like this with CRDs. We have this AWS Controllers for Kubernetes project, which is, again, open source, and it allows you to actually create AWS resources using the Kubernetes API. It has controllers that deploy in S3 buckets, create an ECR repo, whatever it is that you're trying to create. This project has more controllers that can create those and manage them with your workloads. But how you talk to the Kubernetes or the AWS APIs is the same as you always do from on-prem. And you say, I need an identity, I need a secret or an IAM of some sort, and I need to be able to talk, give permissions to talk to those endpoints. So another question here of, will there be priorities between EKS-Anywhere and EKS in terms of pod, node group, and node? I don't quite understand the priorities question.
I didn't understand it. I asked him to elaborate his use case. I'm guessing he's thinking that this is the same cluster and the workload will have a priority to run on on-prem, not on public cloud, for example. And now public cloud is a gray area. What is it, public cloud? Is it AWS Outpost? Is it local zone? Is it EKS-Anywhere? I'm not sure what is cloud anymore.
Right, and in this case, like, again, EKS-Anywhere and EKS are all about provisioning you the cluster. We get you to the cluster API or the Kubernetes API and authentication. We say, hey, how do we get you that infrastructure? How you layer workloads on top of that is really up to you. If you want to load balance between clusters, if you want something that is shared, like, hey, I want to deploy this workload and it goes on-prem first and then it bursts in the cloud, those sorts of things. That's all workload management. Those are all on top of Kubernetes. Those are all things that this project, EKS-Anywhere, is not focused on solving. This is all about getting you a reliable, stable Kubernetes cluster on-prem. And once we get you that, the Kubernetes ecosystem is amazing at getting people all the options and choices they want. There are so many different projects in ways that you can deploy those workloads. And even in EKS, we're not opinionated about how you run your clusters. If you have multiple regions, if you have multiple clusters per region and AZs, all of that stuff, we can help you. We have some best practices. We have some guides on like how to do it at the infrastructure layer, but we're not necessarily prescriptive about, hey, use this tool to deploy your workloads, because that's about workload federation, and a lot of that depends on what you need out of that workload. How critical is it? How much redundancy do you need? How much, what is your HA strategy? So if you don't actually need that, if you're running jobs that could be, deleted at any time and they're not actually critical, okay, if you just need to burst somewhere, like that's up to you on where you want to run that and how.
He elaborated a little bit. He said redundancy, high availability. So I will ask the questions if I think I understand them, what he wants. Let's say, so basically we are constrained by the provider. Now you use the Docker provider, but if I use the vSphere provider, how can I deploy a high available cluster on vSphere? Does it know about topology? For example, will it know like it can deploy across hypervisor or across data centers?
In this beta, at least, it's all about you talk to your vSphere endpoints, and so vSphere can have those different data centers, and you can make that HA topology inside of vSphere is what you mean.
Yes.
In this case, I believe, if I remember correctly, with this beta, we're talking to a single data center at a time. So what happened there? Oh, my cluster upgraded. Sweet. we're talking to a single data center inside of vSphere at a time, and we're creating multiple clusters in each data center because you don't necessarily want to mix. If you have a failure boundary, you don't want to have one cluster spread across those failure boundaries. You do want to have isolated clusters with different fault tolerances for, hey, this cluster is going to go, if this data center goes down, what happens to my other cluster? And as soon as you start getting a cluster that has a mix of like, hey, half my cluster's failed, you have different concerns. And so by separating it out and saying, hey, put a cluster in this data center, a cluster in that data center, workloads is what's important on top of that. That's where you orchestrate, hey, I have 50-50 and I have a load balancer in front of both. And the load balancer can do health checks and whatever it is that you want on-prem to say, hey, just send my traffic to whatever's healthy. And if you're deploying that workload to multiple data centers on-prem, if you have 3 data centers and you say, I need this deployed in every data center, you can for loop that and just say, okay, deploy this, in multiple data centers, or you can take a look again at all the different workload management, but then you put basically a load balancer in front of that does those health checks wherever your global endpoint is. Or if you want locality based on like, hey, anyone that calls it from, this data center should get this endpoint. That's all up to you. Your topology inside your data center is actually responsible for that. Kubernetes isn't doing any of that for you from inside the cluster with those workloads.
I guess as any other infrastructure as code tool, it needs to integrate with other tools also, like maybe vRealize to create affinity and anti-affinity rules and stuff like this. We cannot expect it to do everything, correct?
And yeah, like the Cluster API project is doing a lot of that great work in the community, where Cluster API this is mostly people that either work at these providers or have deep knowledge of how these setups are working. So by using those providers, we can gain some of that experience of, hey, what does it look like in vSphere? What does it look like in OpenStack? What does it look like in Proxmox? So there's like all these different on-prem options that people are doing. And a lot of times the community is able to say, hey, I have experience in this piece. I will go ahead and help you with that and get some best practices in the controller. So the data is consistent. The data is the same as far as the CRD is concerned of like, hey, I need a machine pool, but how that gets deployed and how the controller actually acts on that, those are the things that are up to the provider to implement and actually, push out. And so in EKS-Anywhere, we're able to distill those down and say, hey, these are the best practices we've seen with that provider, with that data set. And so in some cases we can make some defaults, some sane, assumptions on this is what you should do. In other cases, we give you, those extra configurations of saying like, no, I have a custom template that I need to do X, Y, and Z with. And so, okay, well, here's how you configure that as well.
Okay. Sorry for interrupting, but I have asked a question that I want to ask about that I have already showed here. Will EKS-Distro include AWS components that communicate with AWS services? Like, I want to know if EKS-Distro include a Kubernetes network or storage plugins, or to communicate like with AWS KMS encryption provider or such.
AWS or EKS-Distro has a lot of different components that we build. I'm trying to remember where the list of it is. So if I let's look at their most recent release. Here's all the actual components that get built that we have as part of this project. And we say, okay, we have the standard things you would need for a Kubernetes project, but then we also do have a couple things like AWS IAM Authenticator, where, hey, we can build that and we can, publish that as part of this, a pause container, like some things that like maybe aren't like crucial to some people, but it's like, hey, like we actually at a certain scale in EKS, like we wanted to be able to have some patches to this. And so we build it and we release it as part of EKS-Distro. There's nothing in EKS-Distro or EKS-Anywhere by default that's communicating back to AWS and making any sort of like special connections. So just like EKS-Distro, EKS-Anywhere is going to be open source. And it's going to be available for free for anyone to use it and say, hey, I want to get started with this thing. I want some tooling around EKS, but I need to do it on-prem. So EKS-Anywhere, we're making that the same thing that we're doing with EKS-Distro. We're publishing this. It's going to be free and open source. And if you want to connect it to AWS, if you say, hey, have a need to like communicate to AWS, hey, I want to pay for support. All of those things are obviously going to be optional. And we say, hey, like if you want to opt into these things, if you want to talk to the EKS console or something, like we'll be able to make those integrations. But the core of what EKS-Anywhere is going to be is an open source project that people can run in their own data centers without you don't have to be an AWS customer to run EKS-Anywhere. Like you'll be able to take the bits and deploy it locally. Yeah, good point right here about EKS-Anywhere. So EKS-Anywhere is a different model. EKS-Anywhere, we run the control plane in AWS. You never run a database or a control plane or whatever inside of your data center. EKS-Anywhere is completely managed control plane. And then we needed a secure way for all of the nodes in your cluster to be able to talk to that secure endpoint that we manage the control plane. And with that, we're using the SSM, the used to be simple session manager, the session manager agent to create a web tunnel back to the API, because we didn't necessarily want people to always have direct connects. We're not going to send it always over clear text over the internet, those sorts of things. So the SSM allows us to make a tunnel back to the ECS API. And that's a different model here, where EKS-Anywhere, we are running the full control plane in your data center. So if you have a disconnected data center, you can run EKS-Anywhere. You can't run EKS-Anywhere in that case, because you have to be able to talk to AWS APIs to do that communication on like scheduling. And so whenever you're scheduling a workload with EKS-Anywhere, you talk to AWS, talk to the ECS API, and then that comes back in and schedules on your worker nodes. You basically have a task definition of, I want this to be an on-prem worker, and it ECS control plane looks for that. So EKS-Anywhere is different, where the API exists in your data center, and all of your communication doesn't have to leave your data center. And which is, for a lot of customers that we were talking to on-prem, they wanted that model, because they said, this is something that we don't want to like have to talk to Amazon for. And again, just EKS-Anywhere, if you want a fully managed control plane and schedule containers on-prem, it's another great model, because you don't have to run that stuff. You don't have the complexity of that. You manage just your worker nodes, and you say, hey, I have an Ubuntu box, I have a Debian box, I have Red Hat, whatever. Get the session to talk to it, to AWS, install Docker, and you're ready to go. I'm trying to see any more questions that came in from that. But yeah, that's essentially the pieces that we want to show off here. If I look back at my cluster, I showed here that we got it to a 121 cluster by doing a rolling upgrade, even locally in Docker with my local containers. I was able to shift those over from 120 to 121 by doing this rolling release. And you can do this in other providers. You can do it at different scales. If you have 100 worker nodes, you can roll those as well. And Kubernetes handles all of those on top workloads. Kubernetes is saying, hey, that worker is going to go away. Let me reschedule those pods and get those, up and available. And so your on-prem HA story is still just using built-in Kubernetes concepts of how do I shift these workloads once my cluster is going away or nodes are going away. Will there be a private link to reach EKS-Anywhere on premise? If you have private link, you want to talk to AWS APIs for deploying AWS services or talking to the S3 or ECR. You can use private link in your data center. You don't even need, in a lot of cases, like private link is at the network level, right? You'll have like a VPN on your network that talks to AWS. So like the machines don't even need to know about it. So that's able to talk to other AWS resources. If you're looking at talking to EKS-Anywhere from the EKS console, yeah, we would love to enable that. We would love to have an option to, if you want to see your clusters, EKS clusters that are fully hosted and EKS-Anywhere clusters in the same console, we would love to enable that. It's something that we'll definitely look at in the future.
Do you think that ECS and EKS-Anywhere can be able to run Windows workloads now?
There's none that I know of. I don't think EKS-Anywhere supported Windows workloads yet. They might actually.
Is there a demand from customers?
There is. I mean, there's demand from customers for everything. Customers want whatever, like there's Raspberry Pis that, people want. And there's, I'm sure there's some people that want it to run on like an Android device or cell phones or something and turn anything into manageable compute. And customers, if there's one thing that I've learned in my time here at Amazon, it's customers do everything. They have such variety of workloads and amazing constraints and requirements that I would have never thought of. As someone who did my own workloads, it's like, wow, like how did you get to the point that like this was the requirement? It's like, oh well, here's what we had to do. Here's our customer. Here's our regulations. Here's some restrictions. Here's the resources we have, and it makes sense. Like those stories make sense on how they get to that point and saying, this is what we have to do. But being able to enable every situation, that's just a matter of like how can we help them be more successful, and in that case it's just prioritization and time and resources, like people and time resources that we have to be able to do these things.
All right.
I don't have anything else really wanted to show off. Again, look for EKS-Anywhere coming out. We're trying to release it as soon as possible. I promise. If you're following me on Twitter or the AWS blogs, like once it's available, I'll be making a bunch of noise about it. But this is want to show off early version just to let people understand some of the components that make it up, how the workflow works, and then just some of the benefits here and differences between EKS-Anywhere versus EKS.
Okay. Alejandro is not an AWS employee, correct?
I'm sorry?
Alejandro, the gentleman who asked the questions.
Is Alejandro here?
We have 3 AWS vouchers. So Mohammed, you got one. Alejandro, you got the second one. And Khalid Rad, these were the active people asking questions. You got the third one. If you basically get in touch with me, DM me, Twitter, LinkedIn, whatever, and I will get them to you. Thank you, Justin. Thank you very much. It's very informative. Now I know the history of Cluster API. Krisnova is involved in everything. That's amazing. And yes, we would love to host you physically here and take you places and stuff, not just technical.
I'd love to see
take you everywhere, not anywhere.
we will be honored also to welcome you here in Tunisia, both of you, in fact.
Yes. So Tunisia, if you are a Star Wars fan, you can visit Tatooine, and you can see the movie set. Yes.
Yeah, it'll happen someday.
I can see that EKS-Distor is really revolutionary, let's say. It can help us to manage EKS very easily and with less stress about updates and stuff like that. So I hope that we will use it soon and have you host another time.
Yeah,
well, definitely.
Yeah, once it's available, I know we'll be doing. I have a Containers from the Couch show with AWS that we also do. So look up that if you want to see like post GA. I'm sure we'll have something there. But also there's plenty of other meetups and KubeCon coming up and everything else that's coming around. We would love to talk to people, see what they're how they want to use it, where they want to use it, understand the needs, and maybe like how we can help you be successful with Kubernetes.
Yes. Do you think that it is right to compare it with Anthos and Tanzu Mission Controller?
I've never used Tanzu Mission Controller, but I think I understand like the basics. Where yeah, they in both cases they want to be helping you be successful with lots of Kubernetes clusters, wherever those clusters are. How they go about deploying that, and in some cases they're using Cluster API as well, where there's hey, under the covers here, this is Cluster API. They work with providers too, and they have different assumptions they may have made and different ways they connect back. Things like I believe Anthos and Tanzu both require you to be customers and have contracts to use.
Yes.
They both might have some defaults on like they automatically will connect back to their centralized management platforms. And so in this case, like we want to enable people to run it anywhere, to run it under any conditions as an open source project without requiring you to be a customer. But I do believe the like basic goals of helping you distribute and deploy clusters wherever you have infrastructure is fairly the same. They might go into a little more details on like above that like cluster endpoint of like, hey, we have a cluster running now. We want to help you manage workloads. We want to help you do other things. I don't know for sure, but those might be different goals than what we have with EKS-Anywhere.
Okay. And how about policies, pushing policies? Because now if I have a hybrid cluster between on-prem and the cloud, or between different on-prem data centers, I would like to make sure that I have consistent policy across. It's not just the infrastructure what is worrying me. It's actually the compliance and the governance. If I'm running on-prem, most likely I have a data residency, data governance reason why I am running on-prem. So compliance comes along with it.
And I mean, in that case, like Kubernetes gives great reporting and great ways to, like a Kubernetes, say webhook, right? I have a mutating webhook. I won't accept data based on, how you have a configuration in a deployment, because this is able to do everything through Kubernetes API. You can do the same thing. You can have a webhook that looks at your CRDs as they come in for a machine pool or for a new cluster and say, hey, I don't like the webhook doesn't allow that. And so you can block that at the API level before the controller ever even sees it. But all of those same policies and controls that Kubernetes have, none of that is actually specific to built-in Kubernetes objects. Like those are CRDs, any sort of data in the API, you can have the same controls on them. So you can do that at the Kubernetes API level of saying, hey, we don't want this in here. I can block it at a webhook. I could, do reporting on it. All of those things are available because of that really rich API at the center.
Yes. So my question is like, how do I make sure that if I am like configuring OBA or Kevarno or any compliance tool, even OpenSCAP, that I make sure that it's consistent across the cluster. If I change in one cluster, it goes through the other clusters.
That's a workload. That's a piece on top of Kubernetes in a lot of cases, where it's like, hey, we're deploying a workload. And again, in this case, EKS-Anywhere is not solving or isn't even targeting workload management across multiple clusters. We're really focusing on the infrastructure, the Kubernetes API. And so how you're managing those workloads and configuration beyond that. There are some other options for like standard add-ons. Like we have Kubernetes add-ons, or EKS add-ons, which we allow for like, hey, let's get some common add-ons and make them easier for people to bundle together and deploy. But a lot of things are still, people are doing, GitOps for like a single repo that you have GitOps controllers inside those repos, and then they pull that configuration down and make sure that desired state's in place. And actually with EKS-Anywhere, we have a GitOps model for managing clusters as well. So we can install a controller in the cluster like Flux, and you can point it to a Git repo and manage the state of your cluster through that same workflow.
All right. I don't see any more questions. Dorra, you're okay?
Yes, I'm very attentive.
All right. Thank you, Justin. Thank you very much. And hope to see you on the containers on the couch soon. And would love to see the EKS-Anywhere coming out of beta becoming GA. We learned a lot, and I hope our community will learn a lot also. And this is very interesting with all the data residency, data governance, and all the issues of hybrid cloud and multi-cloud. I think we need that. We need it now. Yes.
All right.
All right.
I would really love to have a lab when it will be already released, and to build a really consistent Kubernetes cluster with AWS Distro. So I will hope that we'll see you again very soon.
Yeah, it's going to be great.
Okay. Thank you, everyone. See you soon. Thank you. Bye-bye.
Bye.
Bye.